Hi. This question is about Pyro. Basically, many people ask on Discord what changed with the new Pyro Sparse solver. And Houdini 18.5 introduced a lot of different nodes that help you to get a better and faster workflow with Pyro. The real-time VFX course is not a course with the aim to teach you how to properly use Pyro. Basically, you should already know which kind of procedure you need to get a Pyro simulation. I suggest you, if you want really to understand the workflow and you want to learn amazing tool and procedure to get great Pyro simulation, Rebelway have a fantastic course that is a masterclass for explosions. And in the masterclass, you will go through all the custom workflow and all the tool that you need to know, both from scratch and with the newest tool for Pyro, in order to get amazing explosion. So here we will not go through how to get an explosion with the new Pyro Sparse. I will just introduce you a little bit what you need to know to use the new Pyro Sparse solver. So basically, let's make a very simple example. Let's drop down a geometry. Let's say that we want to make a smoke puff. Let's say that we have a sphere. Our sphere will be polygon, and I drop down a mountain node. Let's say that is like that. I want less roughness. Okay, let's say that we want the normal and post compute normals. And here we have our mountain with the normal. And we want to create a velocity. We multiply our normal with turbulent noise. This will be our velocity. We want to promote the type. Let's say 3D noise. And all the parameters. We want to display the velocity. If it do not display, be sure that you have this enabled, and here you can check if you have V enabled. And we want to have bigger amplitude, and that's it. This is our velocity. We drop down a point velocity node. We keep incoming and we add some curve noise. We increase the swirl size, so basically, okay, decrease a little bit. Okay. Sounds good. Okay, we have our velocity. Let's say with the classical workflow that we wanted to source the smoke here. We want to source the smoke. We want to scatter maybe inside the volume, let's say, or just keeping surface scatter. We want, we say the source volume. So basically we source the density and temperature. We have also velocity. And basically we can noise. This the noise actually changed a little bit from the previous one. So basically you should select which kind of value do you want to noise. In this case we want the density that is not a vector but is a float, and it should show you the value, but sometimes doesn't work. So what you can do is you can just drop down a color node and ramp from attribute and say density, and in this way you will see the result of your attribute noise. Let's say that we should just check if density goes, you see we have negative numbers. There is probably the possibility to post-process, as you can see, and we can just say, okay, just clamp to 0. Because I selected zero-centered noise, so basically it goes also with negative. But let's say that we want not 0, but is density, so probably 0.25, and we do another attribute noise for temperature, and we pass here, we copy, we get temperature, and here we can change in this way. We have a better view for temperature. We want this, but we want to animate it and animate it. Okay, and we want a volume rasterized attribute. This is basically the same exactly workflow that you will see, that you have seen inside the core. It doesn't change anything. We blur the velocity, and that's it. So basically this is our source. We can say no. Okay. So let's create a DOP network. And let's try the old Pyro solver. So basically we have the smoke object here, the old one. We just put gas, resize, fluid dynamic. We put a volume source. We should source smoke, and we go towards the smoke out source, and is the last one. And here we should say density and temperature. And here we have our simulation. We can just add lights here, distant light 1, and okay, second light here, that we have this one a little bit more blue, will be 125, and this one will be a little bit more warm and will be 0.75. Okay, so here we have our simulation, and this is basically, let's say, the old workflow with our original Pyro theme. Let's say old, but let's say that we want the new one. So for smoke, the good news is that it do not change so much. It change, of course, the let's say the combustion mode, but it doesn't change so much the workflow. So basically, you should drop down a Pyro Sparse here, and a smoke solver, a smoke object Sparse, and you should source the volume. That is the same. And one thing that I suggest you here is enlarge fields to contain source. You should have, okay, we should source smoke. And as you can see, our simulation starts. So one thing that you have seen is quite strange for now is the fact that the smokes disappear immediately, because there is by default a strong dissipation right now. So as you can see, our simulation goes. One thing that you have noticed probably is that I didn't put any gas field resize dynamic, basically because the Sparse solver already have this enabled. So basically you have already this function that works for you. One thing that I suggest you is to tune it, because if you go inside advanced and resizing, you see you have some reference field. I would add temperature field, and as you can see right now it works a little bit better. You can increase the padding size because it helps to get less artifacts. One thing that is interesting to mention right now is that Sparse gives you an hint that this solver doesn't have only a different combustion model, it have also a different way to calculate and optimize things. So basically it goes a little bit faster if you use the so-called sparsity. But the interesting thing is that it's called sparse, I guess probably to get a distinction from the old one, but it doesn't mean that you need to use the sparsity every time, because as you can see right now, you can have some artifacts for fast going element inside the simulation. Of course, you can decrease the velocity. In this case, it probably is too high, the velocity of the smoke, but it's something that you should keep in mind, that these some artifacts can arise with the sparse. So let's say that you want to disable the sparsity. Let's say it will be a little bit slower, but it will help you to get rid of some artifacts. You can do it, for example, I mean, you can also change the simulation and tune it to try to get rid as much as possible of this, but this is not, I repeat, is not a video about making simulation with Pyro Solver Sparse. It's just to introduce you how you can adapt your workflow that you used inside the real-time VFX course to the new Sparse Pyro Solver. I will just give you some hints on how to orientate yourself inside the new workflow. So if you want to try to get rid of the sparse, just remember that you have two places, both in the smoke objects and inside the Pyro Solver sparse. So what I suggest you is just to copy one parameter and paste it inside the other module. So basically, if I just say disable, you will have it disabled also in the other one. And as you can see, we have some other issues due probably to the resizing, but it works much better, and you have less of this issue, a little bit less. Of course, you should work with the other parameters, but the important thing that you understand is, okay, if you want to get rid of the sparse solving, you should go inside both the parameter to get rid of it. The Pyro Solver have some, you can find, for example, in the advanced, the resizing tab. So basically here, you can, for example, change the padding and add extra field for the simulation, and you will have also the sparsity, and you have the advection method, the different advection method to change, and here you have in the simulation all the elements that goes through the simulation. So for example, we can say buoyancy scale 0.5 and it will have less buoyancy. And you have packed inside Flame data that you will use, for example, for explosion, for injecting flame temperature and smoke sourcing from the different field, the flame field. Into the shape, you have some pre-made micro solver, like you have dissipation, you have disturbance, you can say, for example, 3, you have shredding and turbulence, let's say 0.2, and this will of course change the look. Let's say 30, and as you can see, it will change the look of your simulation. So we have seen how the Pyro Sparse works, and I repeat, it's not a video about the workflow itself, but it's just to show you how the system works. So basically, you just need to remember that you don't have this to plug it, but it's already there. You have the possibility to have a sparse solver or not, and I will just show you also another way. Let's say I'll drop down a sphere. and I just use for now the Sparse Pyro fireball. And okay, and if we check, okay, let's check these fireball simulation. We get rid of the theme for now. Fireball, and we have our fireball. So if we go inside, we have this, and you can see that okay, it doesn't use this because it introduces the new object that is the Pyro burst. We will see in a little bit what is this, but just go inside the top network. It's very basic, but one thing that you should see is that we have a different field to source. In the old one, there was the burn field. Right now we have just the flame field. So basically what changed in sourcing for explosion in the new Pyro Solver Sparse is that you will have the flame field to source. And as you can see here, it used divergence and flame, and it sourced them from burn. So remember that you will have this change inside the field to source. That is the so-called flame field. So let's try. I will just prepare source path. Let's say geometry. And I will start a new video about it.